Hey guys, welcome to this video where we will be discussing the Intermediate Value Theorem. The Intermediate Value Theorem is a fundamental concept in calculus and analysis, and it has numerous applications in real-world problems. It's a fancy sounding theorem, but don't worry, we'll explain it in simple terms. So without further ado, let's dive right into it. So what exactly is the Intermediate Value Theorem? Simply put, it's a theorem in calculus that states that if a function is continuous on a closed interval and takes on two different values at the endpoints of that interval, then it must take on every value in between those two values at some point within that interval. Now, let's break that down a bit. First off, what is a closed interval? It's simply a range of values that includes both endpoints and is denoted using square brackets like this. Secondly, what does it mean for a function to be continuous? Well, a function is continuous if there are no sudden jumps or breaks in the graph. Think of it like drawing a line on a piece of paper without lifting your pen so that there are no sudden breaks or gaps in the line. So putting those two concepts together, the Intermediate Value Theorem says that if we have a function that is continuous on a closed interval a,b, and that function takes on two different values, let's say f of a and f of b, at the endpoints of that interval, then the function must take on every value between f of a and f of b at some point within that interval. Let's look at a real-world example to understand this concept better. Now, imagine you're driving from your home to your office, and your office is 10 miles away. If you leave your home at 8 a.m. and reach your office at 8:30 a.m., then at some point during your drive, you must have been exactly 5 miles away from your home. This is because your distance from your home started at 0 miles and ended at 10 miles, and you traveled continuously. So you must have passed through every single distance in between, including 5 miles. To make this concept clearer, let's look at another real-world example. Suppose we have a continuous function f of x that represents the height of a roller coaster at a given point x along the track. The roller coaster starts at a height of 10 meters and ends at a height of 40 meters. According to the Intermediate Value Theorem, at some point along the track, the roller coaster must reach a height of 20 meters. To see why this is true, consider that f of 0 equals 10 and f of 100 equals 40. Since the function is continuous, there must be some point c between 0 and 100 where f of c equals 20. This is because the function cannot jump from 10 to 40 without passing through every value in between due to its continuity. Or more generally, if you have a function that starts at one point and ends at another point, and it is continuous, it must pass through every value in between those 2 points. This theorem is really useful in calculus because it helps us prove that solutions to equations exist even if we can't find them exactly. Now let's look at another example to make things clearer. Say we have a function f of x equals x squared minus 4x plus 3, and we want to know if it takes on the value 0 within the interval 0, 2. First, we need to check if the function is continuous on that interval. Since f of x is a quadratic function, we know that it is continuous everywhere, so we're good to go. Next, we need to check if the function takes on two different values at the endpoints of the interval. So we plug in 0 and 2 into the function to get f of 0 equals 3 and f of 2 equals -1. Since those two values are different, we know that the function takes on two different values at the endpoints of the interval. Furthermore, they have opposite signs. One is negative and the other is positive. So we know that the function must take on the value 0 since continuous functions don't jump. Finally, by the Intermediate Value Theorem, we know that the function must take on every value between f of 0 and f of 2, which are 3 and -1 respectively. And sure enough, if we graph the function, we can see that it crosses the x-axis, i.e. takes on the value 0 at some point within the interval 0, 2. So why is the Intermediate Value Theorem useful? Well, it can be used to prove the existence of solutions to equations. Since if we can show that a function takes on two different values at the endpoints of an interval, and we know that the function is continuous, then we can be sure that there is a solution to the equation somewhere within that interval. For example, the Intermediate Value Theorem can be used to prove that there is a solution to the equation x cubed minus 3x plus 1 equals 0 somewhere within the interval 0, 1. And that's it for the intermediate value theorem. It's a simple but powerful tool in calculus that can help us understand the behavior of functions and prove the existence of solutions to equations. I hope you found this video helpful. If you have any questions at all or comments, please leave them down below. And don't forget to hit the like and subscribe button. Until next time, guys. Thanks.